Hello, I'm Vexed, and today I'm going to be showing you how to create a distributed computing system using NaDCS. Before I begin, it's worth mentioning that this video is being recorded during the first beta release of NaDCS, and will likely have changed by the time of your viewing. To begin, we'll have a look at our client. This is a sample application that will benefit from distributing its work throughout a cluster. We can see that it does a couple things here, but let's break it down. First, it connects to the scheduler or node cluster. I'm letting it use the default parameters of localhost for the address here. Second, it propagates taskable code to all the connected nodes. More on that later. Third, it schedules 4 tasks. These tasks, once received at the scheduler, will be load balanced between the nodes in the cluster. Fourth, we wait for the results to be returned to us and then print them to the console. Okay, so how do we create taskable code? Well, it's actually very simple. Here inside a sample taskable library, we see it implements the iTaskable interface. This requires a unique ID to be defined for this task and a callback method to be implemented for when the scheduler tasks us with work. We can see that this callback also receives the parameters passed by the client for the specific task to give us context. It's also worth mentioning that the client can load and unload taskable code from the nodes in real time with no need to recompile or restart the nodes. This creates an immutable create and forget setup process that is very intuitive and easy to use, allowing rapid deployment and high scalability. Now we can go ahead and set up our node and scheduler containers. We'll start by setting up the scheduler by pulling from imvexed/NaDCS scheduler. We'll assign it 2 ports, one for the web interface and one to listen for nodes on. After that, we'll set up 2 nodes by pulling from imvexed/NaDCS node and give them the IP and port of the scheduler to connect to. As you can see, all 3 containers are now running. From there, we're ready to go. We'll start the client and see that after a moment, it lets us see what the tasks have returned, and that they all slept for 1 second each. We can also see that in the web interface, it has logged the taskings and which client they were distributed to. Well, that wraps up this demonstration. I look forward to see what you all create with NaDCS.